नमस्ते everyone. खुश रहिए. I JVWU Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in the JVWU University and the Faculty of Education and Methodology. So today it's well known that your program is MTech second semester, and your course name is Parallel and Distributed Computing. Now, in this today I will discuss the one session name. That session name is your MIND and SPMD. Two topics I will discuss in today's session. So, to make you better understanding about this MIND and SPMD, I just want to share my own created word files. So, please wait for 1 minute. I'm just sharing that files to here. And just starting before this MIMD, I just want to clear to you that I have already discussed the SIMD in the previous session, isn't it? So please do that, revise that once. And so here MIMD. What is the meaning of MIMD? MIMD is the numerous instructions. So the same the multiple instructions and multiple data streams. What do you mean that does this mean? Multiple instructions and the multiple data streams. In this association, all the processors in an equal PC. All the processors are in equal PC can execute various guidelines and work on different informations simultaneously. Whatever the instructions or the input you will give to them, they will work on that input and also give you the some simultaneously informations regarding with that, isn't it? And that all PCR in, processors of the PCR in the parallel. So MIMD, every processors have a different programs and a guidelines stream and is produced from the each program. So this is the diagram which shows you the MIMD. You can see here that there are various M. M is the basically memory and P and CO who is just used to control the controlling unit. This executions we are numbering this one, and the interconnection networks is also situated here, who is connected with these calls and maintaining all the things, isn't it? Processing unit is basically controlled by the control unit, and memory is attached with this one that you are saving your data into the distance, and this all is done with the help of the interconnection of the network. So this is used. Okay, and now comes to the next topic, to the SPMD. So before starting that SPMD, I just want to say some things that please read these sessions from the different book, standard book, and the different multiple online sites on which this will be available, like the Java 8 points, Java and tutorial points, and also the gigs for gigs, isn't it? So now comes to the so more about the MIMD, if we talk more about the MIMD, so we can also say that MIMD is a multiprocessor. It is well-known machine which is capable of executing the multiple instructions on the multiple data streams, isn't it? So each PE or whatever you can say like that, uh, just each processing elements, isn't it? Each processing elements in the MIMD models has separate instructions and also data streams. Therefore, machine built split. Machine built using this model are capable to any kind of applications, and unlike the SIMD and MIST machines, personal uh, processing elements in MIMD machine works asynchronously, isn't it? And MIMD machines are broadly categorized into the shared memory MIMD and distributed memory MIMD. This is basically based on the M, which is the memory part, isn't it? So, based on the ways of what processing elements are coupled to the main memories. In the shared memory MIMD, the tightly coupled multiprocessor system you can say, all the processing elements are connected to a single global memory. In that switch shared memory, all the processing elements are connected to the shared global memory, and they all have access to it. The communication between processing elements in this model takes through the shared memory, and modifications of the data are stored in the global memory via one processing elements, and is visible to all the other processing elements. So dominant representatives shared memory MIMD systems are silicon like graphics machine, and some IBM's SMP symmetric multiprocessing, you can say that way, isn't it? So it is clear shared MIMD, shared memory, that says MIMD. Now comes to the next point, that is the uh, distributed MIMD, isn't it? So distributed MIMD memory machine, that is the known as the loosely coupled multiprocessors, that is the tightly coupled memory multiprocessor who share, isn't it? And this is the distributed is the loosely coupled multiprocessor systems. All processing elements have a local memory, isn't it? They all have the local memory, but in that ones have the global memory. The communications between the processing elements in this model takes through the interconnection network. Okay, the interprocess communication or IPC channel, whatever you have read in the any previous subjects like the operating system. So this is indeed the network connecting processing elements can be configured to the tree form or the maze form or in the accordance to the requirements. The shared memory MIMD architecture is easier to program but is less tolerant to failure and harder to extend the respect to the distributed memory MIMD model. Okay, so failure in the shared memory MIMD affects the entire system, whereas this is not the case of the distributed model. But in each of the but if you talk about the processing elements, then you can also say that it is easily isolated from each other. So shared memory MIMD architecture are less likely to scalable in nature because addition of more processing elements leads to memory contention. Isn't it? Here is one problem that is called the memory contention in the which distributed memory MIMD. Clear? So this is the situations that doesn't happen in the case of distributed memory, in which each PE has its own memory. As a result of practical outcomes and users' requirement, distributed memory MIMD architecture is superior to the other existing. Okay, so this is the basic things which I have discussed today. And just before this SIMD, that is also, I just want to recall that one again. What SIMD working? SIMD is also a multiprocessor machines which is working in the capable of executing the same instructions on the all the CPUs and operating system, but different data streams, isn't it? And different data streams, machine-based SIMD model as well situated to the scientific computing also, since they involve lots of vector and matrix operations, which I have already discussed in the previous session. Clear, so that the information can be passed to all the processing elements and organize the data of vector can be divided into the multiple memory sets and sets for n processing PE system, and each processing elements can process one data set. Clear? So you can say that there is a data ports and there are multiple instructions code where which is handled by the multiple processors. So this is multiple processor for multiprocessor, and the instruction code is also, and data ports is also, isn't it clear? So dominant representative SIMD system is correct vector processing method. or you will know that MIMD is similar these things in which multiprocessors are attached with the multiprocessors, and they all getting the instructions flow and data pool also. That is the example of the MIMD. So today's session is this one, and one more topic I have told you that SPMD. So I just want to share that ones also. Mm, so wait for 1 minute. I'm saving that things. SPMD. Okay. So here is the SPMD. SPMD is basically what? SPMD implied you the single program, multiple data, yani numeric information. SPMD is a sort of equal handling where the subprogram is running the different processes. Different processes, multiprocessor are related, so the multiple documents or the informations are running on multiple processor. Each piece of the program knows what part of calculation is output from the consequences of the calculations and also consolidated by quickly and clear. So now if we talk about the shared memory, what is the shared memory? So on the common memory machine, message can be sent by the saving their substances and the common memory reason. Isn't it? Message is saved by this ones. This reason. This is the regularly the most effective approaches and to programs for imparted memory PC to huge number of the processors. You can what you can save the multiple. This is the most effective approaches which program imparted memory PC to huge number of processors and particularly on machines where memory is involved to the processors and also data another memory for the longer processing. Isn't it? In this also one thing is discussed, that is the blend levels of the parallelism. What is the blend level of the parallelism? Then I will again come for some significant points to the NOMA machines. Okay, so firstly discuss this blend level of the parallelism. So blend level of the parallelism is what? Currently PC averaging many equals and simultaneously of the most extreme joint of that. And some memory program utilizing the MPI, memory program interfaces, may run on the assortment of the verbs. Also, the every hub might be the common memory PC. This is also the entire thoughts of regarding this one SPMD, and also the various CPU utilizing OpenMP. Inside every CPU, SIMD vector directions is basically subsequently by the compiler and superscalar guidance executions. And for example, pipelining and utilization of different practical units are utilized for the greatest single CPU speed. So this is the basic things which I have discussed with you, that basically the important session is your SIMD and MIMD synchronous vector and array. So but SPMD is also in your course, so I have discussed this one. But you have to read out the very mm, you have to read out that things very clearly from the different books and different sites. Whatever SIMD, that is not also considered under the free classification, isn't it? In which you have the in C like SISD, MISD, SI, SISD, MISD, MIMD, SIMD, these all the things. Okay, so please read this out with your own also. And if you have any problem in this session, then please comment or in the comment section box, and also let me know that what problems you have faced if you have in this session. Okay, so this is the overall of on the things, and this is not over. So okay, thank you. And in the next session, I will discuss the next topic, which will help you to better understand do all the things which you ever need to learn, isn't it? So, okay, thank you.